All right, let's try question number 4. What are the non-permissible values and the domain? Now, these two terms are related. Now, in math, usually the domain is all real numbers for functions. However, there's one big rule in math. You cannot divide by 0. So right away, we state x squared minus 9 does not equal to 0 is the domain. That's part B. Let's throw the 9 over. X squared does not equal to 9. You treat this symbol like an equal sign, and when you screw it both sides, you get x does not equal to plus minus 3. So this is the domain. However, the non-permissible values are not in the negative, but it's actually in the affirmative. So you take this domain answer and you simply replace the not equals to with equals to, because these are the rules. What can't you do? You can't be 3 or you can't be negative 3. So you state this non-permissible value in the affirmative. However, they're very closely related. And by the way, the domain, when you say x can't be this, it secretly implies that, oh, by the way, x belongs to real numbers. Everything else is okay except for this, and that's enough. Let's try graphing this on Desmos. So this is a very interesting graph. Notice how when x equals negative 3 or positive 3, we have a vertical asymptote. So by setting the denominator equals 0, we can identify the vertical asymptotes. Furthermore, we know the domain and the non-permissible values, which are closely related. Let's try question number 5. Let's solve. Solve means finding the x-intercepts, or setting y equals 0. Same thing. So 0 is equals to some expression with a denominator. We're not quite sure what the value of x is, but you're allowed in math to multiply both sides by the denominator. So let's multiply both sides by 1 minus 3x, whatever that number is. We're multiplying by 1 minus 3x, and what ends up happening is 0 times 1 minus 3x is still 0, and the 1 minus 3x on the right disappears. So therefore x equals 0. However, what's the domain? Again, the big rule in math is you can't divide by 0. So we state 1 minus 3x, the denominator, does not equal to 0. This is simple algebra. We just move the 3x over, and you divide by 3. Let's take a peek at Desmos. So as you can see, the red graph is the rational expression, and it does indeed have a solution, an x-intercept of 0. Furthermore, the vertical asymptote occurs at x equals 1/3, which we determined by finding the domain x does not equals to 1/3. Now let's try solving this rational expression. We're going to set y equals 0. So 0 is equals to this expression here. But if you multiply both sides by the denominator disappears, because anything times 0 is itself. So this reminds me of quadratics. We can state that 2x plus 1 equals 0, because anything times 0, 0 times anything is 0. Furthermore, we can say x minus 2 equals 0. So just simplifying, we have two possible answers as the solutions. Now what about the domain? We wonder if the denominator can ever be 0. X squared plus 1 equals 0. Throw the positive 1 over, we get a very strange answer. Can you really square root both sides? Can you take the square root of -1? And the answer is no. A number squared cannot be negative. Impossible. So there are no vertical asymptotes. So therefore, x belongs to real numbers, all real numbers. Let's take a peek at the graph. So as you can see, indeed, the roots are -1/2 or 0.5 and 2. And there are absolutely no vertical asymptotes. Okay, so it's your turn.